Hello everyone, let's practice some questions on how to name ionic compounds, right? So I have given you a bunch of formulas and you have to write down the name of these ionic compounds, right? They are all ionic compounds. How do I know that this is an ionic compound? There should be a metal plus a non-metallic anion. So you should always be able to isolate a metal from the compound. It means it's an ionic compound, right? So now first step, so Fe is a D block element. I need to know the charge on Fe, right, before I name it. So how do I know the charge of Fe? We can always undo the crisscross. Now look at the subscript of bromine, right? When we undo the crisscross, I know this subscript came from the charge on the metal, right? So metal Fe should have a charge of 2 plus because there's this subscript, right? And since iron does not have any subscript, I know the charge on the ion Br is 1 minus. I can also tell that from the periodic table. So these are the ions from which this compound, ionic compound, was made, right? So once I know the charge on the metal cation, I can always name it, right? So name of this compound would be iron. Then in Roman numerals we have to specify the charge. Since it's 2 plus, so we'll write 2 and then follow it with the name of the anion, which is bromide. So this is bromide ion. Iron 2 bromide is the name of this ionic compound, right? Now let's do another example. Cu3n. I do not know the charge on the metal cation. Now look at the subscript of the anion, right? It has no subscript. Does that mean the charge on copper is 0? No. If there is no subscript, we can still see that we have still one atom, one ion of nitrogen. So this is 1, right? So this charge is coming from the copper. So copper is 1 plus here, and this subscript is coming from the charge on the nitrogen, right? So nitrogen, we know that it makes 3 negative charge. So these are the 2 ions that this compound is made up of, right? Now since we figured out the charge on copper, we can name this. So this is the nitride ion, right? So the name of this compound, since copper belongs to D block elements, so that would be copper. It has a charge of 1 plus, so copper 1 nitride. That is the name of this ionic compound. Now let's do the third example, AuO. Now look, here there are no subscripts, right? It means they are 1:1 ratio. But from the periodic table, I know that oxygen makes oxide ion, which has a charge of 2 minus. So this is 2 minus, right? So let's first write down the charge on the anion. So we kind of already know the charge on the anion from the periodic table. When there are no subscripts, it's very important to figure out the charge on the cation right. We can only do that if we know the charge on the anion only, right? Since the charge on the anion is 2 negative, then gold should have a same charge, right? The cation should always be positive. So the charge on gold should be the same numerical value as the charge on oxygen, right? Because there are no subscripts. So there are no subscripts. When there are no subscripts, it means the charge on the cation is balanced by the charge on the anion. So gold atom should have a charge of 2 plus in order to make this formula, right? So this happens when there are no subscripts. So be extra careful when you see an ionic compound that does not have subscripts. It means the charges are balanced, right? So the name of this compound would be gold 2 oxide. Let's do another example. Cu2O, right? Now I already know the charge on the anion, right? Since there is no subscript, this is 1, right? This subscript is coming from the metal cation. So copper has a charge of 1 plus. And we already know the charge on oxide is 2 negative, and that is how we see the subscript 2 on copper. So the name of this compound would be copper 1 oxide. Let's do another one. Now silver is a D block element, but it's one of those 3 elements, those 3 metals that only make one type of cation. So we do not have to use Roman numerals when naming the compound of silver, cadmium or zinc, right? Since silver always makes 1 plus ion, and that is kind of evident from the subscript 1 on the phosphate. So this is the anion, right? Silver is 1 plus, and we have phosphate which has a charge of 3 minus, right? So this 3 minus becomes the subscript of Ag, right? Since Ag is one of those 3 metals in the D block that only make one type of cation, so we do not need Roman numerals. Right? So the name would be silver phosphate. We would not write silver 1 phosphate. Right? So this is the right name of this compound. Now let's do this last example, tin SO4 2. I know sulfate has a charge of 2 minus. Now look, so this one is little tricky. Since sulfate has a charge of 2 minus, and this 2 minus should be as a subscript on tin, but tin does not have any subscript, right? So there's no subscript on tin. So how do I figure out the charge on tin? Since there is no subscript on tin, it should have been 2, right? So if I do the crisscross, so I put this 2 here, what should we have here so that we can have this formula? Now the subscript on sulfate is 2, so this should be 4 here. Only then we can reduce the ratio. So if this was the reduced ratio, 2:4 can be written as 1:2, right? So if we had a 4 plus on tin here, right? And then do the crisscross. So sulfate has a 2 negative, right? So tin 2 and then SO4 4. So if I do the crisscross, now I can reduce this ratio to SN SO4 and then we have a 2 here. So this is the kind of formula that we have, that we are given, right? So this means tin has a charge of 4 plus because the ratio was reduced. So the name of this compound would be tin 4 sulfate. So this one is a tricky one. So always remember the charge on the cation becomes the subscript on the anion and the charge on the anion becomes the subscript on the cation, right? Since there was no subscript on tin, we can tell that it was the reduced ratio because the charge on sulfate is 2 negative. So tin should have a subscript of 2. If the charge on tin was 4 plus, only then we can get this formula because the ratio was reduced, right? So that's all. I think that video was helpful. Thank you.